Today we're going to talk about how Volkswagen developed and delivered immersive experiences using a service in Google Cloud called Immersive Stream for XR. And my name is Bernhard Reinert. I am a tech lead manager in Google Cloud for Immersive Stream for XR, and I'm joined today by one of our partners who developed the experience on Immersive Stream for XR with us, Pierre, who will come on later to talk about some of the details. Now we have some different sections that we're going to talk about, and we're going to start with the state of the market. So why would you even develop these kinds of experiences? So in recent years, we've seen an increase in digital interactions. And these digital interactions led to an also increased importance of immersive and extended reality experiences. Breaking this down into different sectors, in the shopping and e-commerce sector, we saw that several retailers and companies had a surge in e-commerce, and some of them had their biggest retail years this year. But we also see high return rates. So the return rates are also at a maximum or at an all-time high. And online retailers are looking for digital twin models to bring accurate representations of their products to their consumers so that they can get a good preview of what the product will look like so that return rates will go down. In the learning and education sector, we see an increased importance of remote learning capabilities, where education companies want to bring immersive experiences to their students so that they can learn and experience these things from home. And finally, in the entertainment and media sector, we see a preference for digital entertainment, and companies are looking for more engaging and immersive content that is interactive or more interactive than the streaming solutions that you see so far. Oops. Now, if we look at some of the numbers here, we see there's several studies about this that show the importance as well. 77% of consumers say that they would shop more if they had XR or extended reality experiences. Conversion rates are also much higher with extended reality experiences, and we see an 11 times increase, and consumers are spending up to 2.7 times more if they have an extended reality experience for the product. And finally, there's already a huge market for this. So 1.4 billion devices are already capable of delivering extended reality experiences to end users. And this is growing at a 30% year-over-year rate. Now, this is not new, and companies are already looking at this. So if we look at the consumer sector, Wayfair, for example, is using extended reality to create previews for furniture that they can place in the real environment, as we can see here. In the education sector, for example, the Smithsonian Channel is trying to bring the Mars rover into your own garden, as you can see here. And in the entertainment sector, Google teamed up with Taito to celebrate the 45th birthday of Space Invaders with a geospatial API experience for Space Invaders, where you can have Space Invaders in your own environment. But we also see that adoption of these experiences is still low and not at a rate that we would like to have. Now, why is that? From our perspective, we see a couple of challenges. The first one is lacking photorealism. For immersive experiences, you want to have photoreal content. And many of these mobile devices that you're using to create or show these extended reality experiences are limited in power on their mobile GPUs. Also, if you're stretching out the power on these mobile GPUs, you're draining the battery on these devices pretty quickly. Secondly, these devices these experiences in many cases are not seamless. So end users first have to download apps or huge digital twin models before they are able to experience the immersive experiences on their end device, making it not suitable for ads use cases, for example. And finally, it takes a long time to develop these experiences. In many cases, you first need to optimize the digital twin models from CAD models that exist to create the models that you can render on these mobile devices. And you need to go through lengthy steps of acceptance criteria internally in companies to get this signed off to be launched. And you also need to develop it for every single target platform that you want to launch it on. So you need to develop it for iOS and Android and possibly web as well. And to overcome or address all of these challenges, we developed Immersive Stream for XR. And here we use cloud GPUs or cloud rendering to create photorealistic images that we then stream down as lightweight video frames to the device. To illustrate the point about photorealism, here on the right side you can see a 3D model that was rendered with the desktop class GPU, and on the left side you can see a similar model that would be these days rendered on mobile devices still. So the goal is to bring the photorealistic image quality to mobile devices. And we want to do this by still enabling immersion and interactivity. So the phone or the mobile device only sends input events to the cloud, where we use powerful cloud GPUs to render these experiences and stream them down as lightweight video frames. So all the device needs to do is just send input events and decode a video frame. So we can create the same photorealistic experience on any device, whether it's an older iPhone model or the newer Pixel model. And here you can see a virtual car experience that we created with one of our early partners, Lexus. We do all of that while being seamless for the end user. As you can see here in a digital or virtual kitchen experience that we created with Lowe's, all the user needs to do is just scan a QR code or click a URL, and the user is taken immediately into the app and experiences the first video frames immediately. There's no app download required because we are integrated into the Google apps on Android and iOS, and we also have a web client that we can use. Also, there's no content download required. This model that we are rendering here is roughly 5 gigabytes in size, and we start rendering right away. There's no need for preloading any of the content. And all of that works on any device, whether it's Android, iOS, or web. We take care of the end client, and you don't need to worry about developing or distributing the client to any of the users that you want to target. We support multiple platforms, so you build the same experience once and you deliver it everywhere. And here you can see the experience that we will later see Pierre present as well for Volkswagen, that runs on a mobile phone but also runs on a desktop, and it just scales to whatever aspect ratio or end user device you are using. For the developer, it's really easy to onboard. So whether you have a 3D model or an existing Unreal Engine project, you can just onboard with 3 simple steps by adding a couple of files to your existing Unreal project. Or you can start with a template project that already showcases a couple of different experiences that we have, for example, for a car configurator or a furniture configurator. And all of that is hosted on GitHub. Everybody can download it and get started right away. Looking at the developer flow, the developer starts by first downloading Unreal Engine from Epic, and also either our GitHub developer project, or they start with their own Unreal Engine project. And they download that to their developer machine or their workstation, where they start iterating locally. Once they're happy with their content, they upload it to Google Cloud Storage, and then create 2 resources. One is the content resource for Immersive Stream for XR, and the other one is the instance resource. The instance then tells us where we want to deploy that content. And from there, we take all of the complexity away, and all the developer then gets is a URL or a QR code that they then can share wherever they want with their end users. And the end users can then look at these experiences on their devices, whether it's mobile phones or desktops, and just use this one universal link for everything. We are, at the moment, we support these cloud regions where we run cloud GPUs. And with these regions, we can reach roughly users in all of these circles that we show here. And this is for a typical experience that can tolerate up to 150 milliseconds of motion to photon latency. Now, latency is a common problem with cloud rendering solution, and we want to make it as smooth as possible. This is why we created a specialized latency correction algorithm for the XR modes that we support. Here you can see what artifacts would look like if we were to use the images that we render in the cloud right away and blend them with the camera image on the client device. And you can see the virtual image starts swimming on top of the camera image, breaking the immersion right away. This is why we render more and try to correct the camera image or the virtual image that we receive on the client side so that the virtual image stays anchored on top of the camera image and keeps the immersion alive. Now, we can deliver industry-leading graphics, And we do that by using Unreal Engine 5, which is an industry-leading game engine. So we meet the developers where they are. And Unreal Engine 5 has two great tools that help us with that. The first one is Nanite, which allows us to create massive, extremely detailed worlds and stream them down. And the second one is Lumen, which allows us to create photorealistic dynamic lighting. On the hardware side, we are using NVIDIA GPUs, which are industry-leading graphics cards. At the moment, we support Tesla T4 GPUs, but we are soon adding support for L4 GPUs. And these L4 GPUs are great at rendering and encoding video, but they're also great for generative AI workloads. And this is why we are starting to experiment with generative AI for virtual backgrounds, for example, here. Here you can see the Volkswagen ID. Buzz model in two different scenes that were created from text prompts. And as you can see, not only does the background change, but also the reflections and the lighting changes depending on the text prompt that we use. Immersive Stream for XR is integrated into the Google ecosystem. So it's really easy to run ads with Immersive Stream for XR, where you can just use Google Ads or the Google Marketing Platform to start your ads. On YouTube, you can create video ads with Immersive Stream for XR and also use the QR code in your video content. And finally, we have an integration with Google Analytics, where you can run custom reporting for the experiences that you want to launch. Here you can report on any custom metrics, such as visitor count or most popular configurations, or any AR interaction that you want to track. We can do all of this at Worldscale. So for one, we can have a large number of concurrent users, and we can render massive 3D models or world catalogs. And we show this by our integrations with Google Maps. So there's a new feature in Google Maps called Immersive View for points of interest, and soon there's also Immersive View for routes. And this is all live in Google Maps already. And here you can see that we can, this is all running on Immersive Stream for XR, and you can see that we can render, or that we can operate the platform at Google scale or Google Map scale, and we can render an entire model of the real world, or the 3D model of the entire world on our platform. Now, there's a couple of customers who are using this already. KDDI, one of the largest telecommunications providers in Japan, is using Immersive Stream for XR to stream or render virtual concerts. And that you can see here on the left side, where they have a huge screen and then render these experiences down to that device. The Singapore Tourism Board is using Immersive Stream for XR to render tourism experience or previews of what it's like to visit Singapore. KDDI, again, is using Immersive Stream for XR for a virtual fashion show. And then finally, we have Volkswagen, who's using Immersive Stream for XR to create a virtual car configurator. And now we'll hand it off to Pierre to tell us more about how Univis created this configurator.
Thanks. Thank you, Bernhard. Thank you for the introduction. It's great to be with you here all in beautiful San Francisco. My partner Mirko and I established Univis X Lab in 2020 as an immersive studio and R&D company. As a team with Hollywood visual effects experience in automotive and gaming, we're offering a unique blend of services from real-time and web development to AI-powered automation. Volkswagen marketing team and Univis share a mutual passion for new technologies, such as AI and immersive tech. Volkswagen is always interested in using new technologies in innovative ways to show customers Volkswagen before it is manufactured. Our journey began with several exciting VR and AR showcases. For this, our first vision was actually quite simple. We wanted to allow customers to visualize their personalized digital car right outside their own homes. However, our early projects were often driven by complex 3D data preparation rather than focusing on creating captivating experiences. To give you some context, the digital construction files of a digital twin can consist of 30 or even 60 million polygons. Polygons are the digital building blocks of 3D worlds, similar to pixels on a screen. This level of detail is a lot for most phones or tablets to handle. Using standard polygon reduction methods would result in something that looks a little bit like a Swiss cheese, so it would be full of holes and looks maybe even distorted. Therefore, a lot of manual work is necessary to make sure that the simplified car model still looks like the original design. Unfortunately, these adjustments also involved acceptance procedures, potentially causing delays in project timelines. This procedure takes up a lot of time, up to 3 months and sometimes even more. Recognizing this, as an R&D company, we decided to find a better way to simplify this process. We developed our own technology to reduce the number of polygons from CAD files and the number of objects displayed in the real-time engine. We combined these methods with AI algorithms that learn and recognize the 3D objects to know when to apply which reduction optimization method. This allowed us to automate the process of simplifying digital twins over time, while preserving the original shape and form. We called our AI geometry optimization technology Solid Matter and used it for the first time on the ID4, which we ported from CAD to WebGL. While we were quite happy with the 1 million polygon model, the final look was still not perfect as we'd liked it to be, because WebGL is unfortunately no Unreal Engine, and it has still quite some render look limitations, as you can see here. Fortunately for the ID Bus AR project, Google ISXR team collaborated with us and VW. Thanks to the ISXR technology, we could remain within the Unreal Engine and could benefit from its exceptional lighting engine and automotive shaders. We also did not have to go down with the polygon count so much. We found that keeping the 63 million polygon model below 50 million was actually the perfect range that completely eliminated the need for any remaining retopology task. All this allowed us to spend more time on the overall experience. In this regard, Google provided us with the customizable template that we effortlessly aligned with Volkswagen brand guidelines. This streamlined the duration for such a project from at least 3 months down to only 4 weeks. Thanks to the model conversion by our AI, the ID Bus was accurately represented, eliminating the need for further acceptance loops. Most of you probably know that users today just don't download apps as many more as they used to be, especially large apps with lots of gigabytes. Thanks to ISXR, there is no need for an app download. That was really great for us, as we did not have to create, publish, and support 2 apps on iOS and Android. Thanks to ISXR asset preloading, even large models load up in 1 or 2 seconds, so that's almost instantly right within your mobile browser. This streamlined delivery ensured the ID Bus was displayed uniformly across all platforms and devices, eliminating extra acceptance loops. I still remember the moment when I augmented the ID Bus in front of my own home in Germany. That's the picture that you see as a stream, and I could not believe how stable the tracking was. It was kind of like the first time that I actually saw it. This marked the realization of our vision we started with Volkswagen more than 5 years ago. Today, we're actively exploring the possibilities of this technology. We perceive the impact of immersive ads as highly disruptive. We found that engagement rates of ISXR ads on the ID Bus were 11 times higher than rich media and 3 times higher than standard 3D ads. In addition to that, Google ISXR technology, when combined with a digital twin powered by Solid Matter, grants the automotive and other industries with the possibility of a single real-time model that can be utilized for streaming AR on mobile phones and 2D configurators on desktop devices. We are offering our Solid Matter AI geometry conversion technology as a service in cooperation with Google today. If you're interested in using Solid Matter for your own ISXR project, you're invited to join our waitlist at solidmatter.io. Thank you.
All right. As I said, you can start these experiences by scanning a QR code, or you can also try these experiences from our product webpage right away. And on the product webpage, we have a link to this experience here already. And if you click it, you're taken into the Google app on iOS, and you start in 3D mode, where you first are shown or presented with a 3D model that you can interact with. You can move the camera, you can zoom in and out, you can enable hotspots to interact with the car model and look at all of the dynamic elements that we have. But you can also customize the model. You can change the paint to something that you like. Maybe this orange looks nice, and the rims you can change as well, and then you can look at the rims in more close-up. Yeah, and then we start with this studio background, but we also allow the user to change the background. We have, in this experience, we have 4 different backgrounds. This one is a mountain road background that we created for this. And you can also jump inside and look at from the driver's perspective, what it would look like. We have a beach scene that we can load. And then, as we seen before, we have a generative AI background that we created here from a text prompt. And then, when you're happy with the car that you configured, maybe we take the yellow color, you can then also start looking at it in augmented reality. You quickly scan your environment, and then you can place it here and look at all of the details that you want to explore further. And this, as Pierre mentioned, this is a really detailed model, so we can look at all of the different details here. We can look at the stitches on the steering wheel, which are all modeled out. We can look at the HUD here and see all of the details that we have. Look at the different seats that we have. And we can still configure the car in augmented reality as well. We can bring up a configuration option here. We can still open the car doors. And then we can also look at the car in virtual reality, where we take over the entire scene and don't show the camera image anymore, but have a fully virtual background. And here we can, for example, look at this beautiful beach scene from the driver's perspective. And you can try all of that yourself as well by just going or navigating to our website to check out the different experiences that we have listed there. Oops. So we don't need that. In conclusion, Immersive Stream for XR allows developers to create photorealistic 3D and XR experiences and create seamless user experiences where the user doesn't need to download any app. And for the developer, it allows the developers to have fast development iterations and a fast development process. If you want to learn more, you can navigate to xrwithgoogle.com, which is our product page, which has all of the details that you need to know, and also a couple of links to the live demos that you can check out for yourself. Now, with all of these sessions, we are very interested in feedback. So if you have the Cloud Next app installed, please rate this session and tell us how we can improve. And we have a bigger presence here at Cloud Next. So we had another talk at the Innovators Hive earlier today. If you want to learn more, our colleagues Mirko and Haenssgen are here as well to tell you more about developer-specific details, how you can get started. And we have 2 demo stations where you can see the demos for yourself. We have the QR codes there, and we are staffing it there as well. And we also have some cool swag there. We have these hats. So if you come talk to us at the demo stations, you can get one of these hats for yourself. And we are at the demo stations for the next few days. Please come by. That is our session. Thank you, everyone.